quite fast, so brace yourselves. This also means that we will have quite a few time to do some error recovery, so if we encounter some errors that we won't be able to overcome in the time of the presentation, then later you will have the whole source code. Later. Okay. What are we going to use for our application? Well, first idea are the fragments. Were they mentioned at yesterday's lecture? Fragments? Not really. Okay, so do something about it. We'll attach some external libraries to minimize the amount of code we have to write ourselves. I'll tell you something about the HTTP and how to connect to the internet, our web APIs, and with parts of JSON, and we'll do the final application. Okay, what do we need for our app? It's a simple activity. We have the concept of activities, as you mentioned before. Within this activity, we're going to have two fragments encompassed with a view called viewPage. It simply uses fragments which can be selected. So we're not going to think of doing some, gesture thing. Just use an element that's pretty in the Android support library. Okay, the data that we're going to use will be the list of archaeological sites and the list of museums that also has images and words and situation. The archaeological sites is only a list of names, so there won't be much interactivity there. Okay, we also want to have an action bar in the platform, and for that we will use the library called action bar. It's maybe not crucial for this project, but I want you to learn how to attach a library using the library project. These are the libraries that we use. We mentioned action bar show, and Android query, which I'll be working a bit later. There's also the Android support library, which is constantly released and updated by the Android team. But when you attach action bar show, support library is attached automatically, so you don't actually see it too much. Okay, so we can start by creating a new Android project, which will be our project. So basically, can you do that by yourself? Here. Here as well. So just a quick reminder: file, Android application project. Let's give it a name, for example, ESS API demo. All the options here below you can leave as they are. Nothing to change here. Nothing to change here, unless we want something that's the item. Not this time. We can create an activity, and we'll do this. Select here the blank activity. And what's important here, you can choose the navigation type from here, but then it will be available only for the devices with ice cream sandwich or higher. And we don't want this, right? There's some fixed types of slide. We don't want this for now, so we leave the navigation type as none. And we've got the first version of the app that basically does have to attach the library called action module. Has everyone downloaded the files that I mentioned previously? Those two. Actually, action module the zip is the one we're going to use now. So now I want to ask you to unzip this file and have a directory called action module. Right in the place where we downloaded it. We'll handle attaching it in Eclipse in a while. So everyone's got it? If you have already got it, we want to open this project Eclipse, and we do this by selecting File, New, Other, and use this option. Android project from existing code. Please point to the root directory, that is the directory where the file was extracted. So in my case, it is here, right? Actually, I can't import it right now because I already have a project name like this. But you should be able to import it. But be careful to check this box so that the Action Marshall project is actually in your workspace. Right? Got it? Okay. Next thing is to attach this library project to our project. So we go for the properties, Android, and here we click this button and simply add the project. Okay. We can try to build it. This part, all right? That's it. Right click your project, properties, Android, and here you can add the project over here. Is it visible here? Yeah? Okay. Alright, presentation. Right. This. This. Okay. Now this is the thing we're going to do. So we're going to open the main activity and we change the superclass for our activity from main activity to shell fragment activity. If you press Ctrl space and it gets added automatically, then that means it's all good. Here you can get an error with the second method, but for now we can just remove it. If you can get this class imported, that means you have attached the library properly. You can also try pressing Ctrl plus Shift plus O. That is the shortcut to organize the imports. It will be shown in a later slide, but it's like a source organizing imports that can help times when the imports get somewhat messed. Right, can we move on? So,
Wenn du schon mal genau in der Laune hast, have it. I read about it, but I don't have the line to know how much not to talk. So I have.
You can just delete all the imports and press Ctrl+Shift O. Organize. So, once you have it, we'll start designing the main screen. The main screen of the UI of the activity consists of only the view pager that contains the fragments and the strip with the titles of the fragments. How do you do that? You already built the app? Maybe running the emulator? Control F11. We see the app launched. Seems to work. Right, can we move on? Alright. Let's get the main activity done. So we're going to edit the activity main.xml file. I'm just removing some unnecessary lines, like those four, and this text will also be needed. Instead, we start writing the XML for the view pager, and here you have to type in all the class name. So it's android.support.before.view.pager. I'll just do it here. We have to add some basic parameters for this view, like layout, width, set it to match parent, height, also match parent. We need an NIT pager, so let's call it the pager. Inside the view pager, as a child view, we include the view called pager title strip. I will use strip at the top, but this fragment that we have. It's Android type of here. Be sure to double check the class name that you enter here, because it's really important to you get no error at the compile time. The app just won't run if it's wrong. Support before you pager strip title. Pager title strip. And some basic parameters as well. So pairs of windows. Still, you know. Okay, so does everyone have it like this? This one, this view, it doesn't need the closing tag because it's finished here with just with the slash. That means it has no child tags. Can you move on? Moving on to the activity code, we need to get this pager, get a reference to this pager. So I'm creating now a field in our main activity class. Good pager, let's call it pager. The M stands for member field. Common thing to name. Class fields like that. Instance fields. All right, and here initialize it, assign a value. We do this by calling find view by ID. Set ID that we specify value. So quick comprehension test. What do you think? How many adapters do we need in a whole application? Right? Remember, we have two lists within a swipeable view pager. So, how many adapters do we need? Anyone? No idea? Close? That's right. We adapters, one for each of the lists, and another one for the view pager, because the view pager actually also uses the adapter, but the views that are returned from this adapter are just the fragments. And I'll show you how to create an adapter for the view pager. There are some differences to what you may have seen yesterday. I will get Can I close this one?
Basically, we resolve as a field.
page that cannot be resolved as a field.
This here,
No, the last line.
here.
Yeah, right.
Did you create the reference here?
Yeah. Measure from r.id.measure. Yeah.
Just say that.
Okay, and did you set the ID here?
Yeah.
Did you say that's not high?
Yeah. You have to save this one and maybe get back here and build the project. So you can press Ctrl V for the project to build.
Found it.
All right, so let's close this one. So we're going to create an adapter. Getting a new class. Right. Is everyone following? Okay. Creating a new class. Let's call it the pages adapter because it will be the adapter for all the pages. We set this superclass to the fragment state page adapter. Fragment state page adapter. So you can just type in the first two letters. Fragment, control space. Select the fragment state page adapter. So must be that it shows some error. New class. Right click the package. Class. The name is here. Here's the fragment state pager adapter. Just start typing this thing. Control space. Content assist. Need you to the right class. Once you have it, click this hint so that the constructor gets ready. But we can alter the constructor here so that we get the context. So let's just add a parameter for the context. We should go to add imports. Adding the context as a field may be useful in the future. Assigning the value of the parameter to the field. We know that we want to have two pages, so two fragments. So we can just set the get count method to always return 2. Now we need to instantiate the actual fragments. We have for now no class that we can use here. So we go on and create 2 new classes, like museum fragment. Here in the superclass is the shell list fragment. It's important that it's a shell list fragment and the normal shell fragment. It simplifies a few things when handling lists. So we don't need much more than a list. All we display is actually the list. Maybe you can do the maps so package so that it's ordered. That's optional. Then you can package to be ESS API demo.museum. All the things related to museums will go there. So it will be the same case for archaeological sites or art sites. just need those classes to be created. I'm not going to enter any code here yet. We'll get to that later. Folder structure looks like this in my case. You don't have to use these separate packages if you don't want to, just for the sake of clarity. I've added some sub-packages. Alright, and now going back to the major adapter, we have this argument right here, this position that is the position that the adapter asks for. So we have to return the correct fragment. So here's a switch here. It's 0. Let's return a new site fragment. In the case of position 1, we return new position fragment. That's the different case. That's a simple switch that returns the correct fragment in the correct position. Alright. There's one more thing we want from our adapter. To override the method get page title, so that we get the title in the string. Here we can use another switch. Case 0 we return case all we'll just return these ones. And a different case which shouldn't happen, in fact. Return this string. It shouldn't be used. Okay, what I've done here is I use a hard-coded string. In general, you should never do this. You should use something like mctf for your context, right? We had the context before. Get string and use some predefined strings from XML. I know if it was yesterday mentioned. Because it allows you to automatically translate the application, just by putting it in front. But just for the sake of this presentation, I'm going to leave the hard-coded string. But just remember, this is not necessarily a good idea. Who's still following? Can you raise your hand? Okay. And who's left out during the process? Let me just check if it works here. Once we have the adapter, we need to set it for places adapter where as the context we provide this activity. Activity is a context. And for the fragment manager, we call get support fragment manager. And that's it. See, there are errors, so let's just try to run it. Here we are. Let's swipe it. There's the loading indicator that's provided by default by the shell list fragment. Nothing loads because we didn't ask the fragment to load anything. Right, we can tap. Place it up. Okay. So we arrived at the checkpoint. I can show you the whole here. So we will make a 5-minute break for you guys to catch up. Resolve some problems if there are. It would be nice if you this level so that we get the swiping views running in our. Or if you want to just go outside, just energizing activities. That's it. Actually, the whole code up until now is somewhere in that section. So, can we check the?
Yeah, talking around here.
You need to attach the shell. If any of you have some import problems, you can just delete all the imports and press Ctrl+Shift+O. Shell fragment work. activity word. Okay, so let's go to this. Maybe just right click specific this project. Save the Okay, so guys, we'll share all the code later, but now we need to get the other things done. So, guys, what else are we doing? It's working. It's great. Otherwise, we'll get to it later. Next thing we have to do is creating the single elements that display the data, and for this we need so back to items. Two classes, one for that will represent a museum, one that will represent archaeological site, and two layouts for the single items on the list. Right, so archaeological site is easy to have only text view. Museum is a bit more complicated, but we'll get to that. For now, let's create the classes for museum and archaeological site. So. No super class this time. What do we need? Now we need to see what kinds of fields we need by checking what's available in the API. So API specifies that every ARC site has an ID, name, latitude, and longitude. So we just have these fields here. Just make them as public. Otherwise, entities with getters and setters. So that's for now. And we'll go for the museum. Museum has basically to avoid setting the getters and setters. It's just faster this way. Just yeah, that's faster anyway.
Which sort class did you use?
For these classes?
Yeah.
No, just the plain old object. These are arbitrary classes. We don't need super class. resources folder. ArcSight with the convention. And here we can have just a simple text view. Okay, environment. We can add something like mean height so that the view isn't too narrow. This may be 60 feet. Okay, this is usually fine. Ready to left, center vertical. Okay, that's it for the ArcSight. Another one for the museum. And for the museum, we're going to use relative layout, which is probably the most flexible layout there is. And wait. Item museum. And here in layout, what do we want from this page? This layout, we have the image that is always on the left to the right of the image. A bit with a bit of margin, but also to the top there is the museum name, and below it there's all these logical constraints between the views. You can easily specify editing the relative layout. So we go in and insert an image view. With a width of 120 degrees and a height of 80 degrees. By the way, another very useful shortcut is Ctrl-Shift-F. It automatically handles all the code structure like indentation, etc. Very useful, especially for editing XML stuff. Okay, let's add something like a scale type for the image view. Scale type is just the way of handling the image when the size of the image is different from the size of the image view. So just with that ID. Let's assign the ID of image. Okay, the image will be set to the left by default, so no need to set other parameters. Now we go for the text view. Set the ID name, because it's the name of the museum. Maybe somewhere. We have to set it to be to the right of the image, so to the right of, and specify the ID of the image. Right. We also add the align parent top, true, and the margin from the top. Say the margin top and set it to like 10 degrees. So that it's not there's some space from the top. Okay. Another text view. Same width and height parameters. We also set here to write image, but below text view the ID name, so it's below the name. There's the margin. So let's say 10 degrees below. For the things to do as well. So name of category, because this is a category. It should be like something like this. Maybe graphical. Yes. Is this clear enough? Need some further explanation.
Could you upload this on the web?
Yes, I will. I'll probably upload it. So don't worry if it doesn't work for you just now. It should. Should be a little bit of when you create a XML file. To use any XML file. Summarize what we have until now. We have those two swiping pages that we want to populate with data. We have the single elements to display, like the view section, and we have the prototype to fill in the actual data that we will get from the parsed JSON files. Okay, moving on then.
Can you move just to the large set? Excellent.
Okay, that just takes you. No big deal here.
Okay.
We can add some padding. Does anybody have this up and running until now? Nobody? Okay. Such a tempo will be a bit high, but it's going to put out my best to get through the data downloading section.
Next to something,
Yes.
why is graph doesn't work? It says I can put left, center, vertical.
What's not working?
The Android graphic, it says I cannot put left, center, vertical. It says it doesn't work.
Did you use gravity or layout?
Gravity.
That's actually.
Yeah,
just for gravity. The other parameters are fine. Right?
Yeah, what is, what's between left and
So we just set the gravity, because when you have the text view, you can just set the text to be different positions. By default, it's to the left and top. So I just wanted to move to center it vertically.
Sure, that's what it is.
That's or at least should be the vertical bar.
Vertical bar, right.
That's not such. I don't know why it's burn my expression, but in fact it's vertical. Also with the gravity? Sometimes after layout changes, you have to clean the project.
Yeah.
So that is. That's okay. Okay, so while you're fixing your layouts, we can move on to theory. We'll now put everything that we've created so far aside and focus on getting the actual data from our web APIs. And we will start by a brief introduction to HTTP protocol. So, what is HTTP? HTTP is basically the language that machines or browsers use when try to communicate. And one of the languages, one of the protocols used for the communication, we're going to use it to get our data. What's the structure of HTTP? Request and response. It works so that when the connection is established, the client sends a request, server processes the request and sends the response. So here's what it looks like. It starts with the verb that means the action that the client wants to perform, and there are 4 of them. Will be like described later. Then it is the next part is the URL to the link to the specific resource. Clients get post. Next are the headers. The headers are just some additional pieces of information for the server to process the data. So, for example, we see that the client expects an answer in the format of HTML file with encoding in UTF-8, etc. I'm telling you all of this because actually our API, we won't see this just later in the code. I'm showing you this just to give you some grasp on how the headers work. They're just lines of parameters in format of key value, right? You have a key here and a value here. And in our web APIs provided by the organizers, we simply have to add an additional header to get the JSON format. Usually you would see this more as a part of the URL, but here we have to add the header. Okay. The response from the server might look similar to this one. And the most important part, besides the actual content, is the response code, which shows us whether the request was executed successfully. That is what the code 200 stands for. There are some headers as well for the response. There's a empty line below it is the actual response. If we wanted to get an HTML page, so like in the example before, we would have just plain HTML code here. This is, for example, the response where a JSON file is included in the response. Any questions? Is that clear enough for you? That's just a brief introduction. Now we need to dive into details. HTTP provides a handful of methods. Most commonly used are the get and post. The get method is used primarily for retrieving data from the server. Web servers, web services, so what we call them, are usually programmed so that the get request doesn't alter the state of the data on the server anyway. So when you paste or type the URL in the browser sends the get request to the server, parse the HTML and shows it to you. Post is used, for example, for sending forms, some data that you want to actually alter the state of the data, add something, delete something, etc. Some translations also use put and delete, but they are not so often used, so we just use them. And today, the only method that we'll actually use will be get, and in fact we won't even see that it's a get, but because we'll just paste URL next to some secret magical library that I will show you right now. I will write on Monday in the lecture of some magical acronym called REST. Said that's some representation of status. I can't even recall the thing. But what it's about, I mean, it's not a protocol. In fact, it's more like some kind of type of architecture where every URL points to a specific resource. Like we have the Twitter example here. When we ask for the statuses slash retweeters slash IDs, it means that we want the IDs of the statuses from the retweeted tweets. The description is taken from the Twitter API right here. Right. Here is the URL that you would use to produce actually this kind of get request. So that's not that important in this case. Just remember that when you use a URL with in our example is something like get museums or get archaeologicals. It means that we actually ask the server to provide us the whole list of those objects. So where's the part? Where's the place for JSON in this equation? Actually, JSON is the format of the data we get here. It's just a way to store the information in a text file in a structured way. So it works like a tree where some of the elements are included in others. Okay. And the basic data types that JSON uses are a dictionary. So these are like pair, where the key is a string and the value can be any other type of data. So you can, for example, include a string or a number or an array or anything that's allowed in JSON. An array is something that uses the square braces, and there you don't have the key. Though it's written here that is the key. It's just the first or zero item in the array, and they're just they're in a sequence separated by a comma. And as you can see, the array can store also different types of other data. So basically that's it. It's a really efficient and straightforward format. It can be easily read by. Okay, here's an example of our data set. As I said before, we need to add a header. That's hackish, but well, that's what the API specifies. So we have to obey. Here's a sample URL that will get us the list of the museums in the JSON format. If makes available to users. So things like the URL connection and HTTP client from the Apache library that's also a part of Android. So you can use them if you know Java, for example. We've written some other applications in Android. You know these classes, they will work as well. But there's a slight problem, and that is credible. To keep our application running smoothly, we need to somehow ensure that all the operations that we schedule to do are quick. Because when we want to redraw something, it has to be on the single main thread, the UI thread, and connecting to the network can take quite a long time, like a second or two, and if you just block this entire thread, no UI updates can occur. Then you have to just wait until the network operation finishes or fails, and in that time, the app just freezes. So we have to think of a solution for that. And basically, this would be the model we're aiming for. We need to schedule launch some kind of thread that will handle all the long-lasting operations in the background, and then provide us with the result. And how can we do this? There are several ways to accomplish this. One of them being the passing task. You can, in fact, see many ways of doing this on some Android tutorials around the web. However, I want to show you something different. There's even better problem when you try to download and or display images. Even if you download a compressed image, it has to be decompressed in order to be displayed on the screen. And how much memory do we need to display such an image? Well, as you can see here, 1024 image can take up as much as 4 megabytes of the memory. So if you want some 10 images like that, we would run out of memory pretty soon. It's even worse when you have those big images, but you want to display only part of them, not in a list like we have in the museum's list, right? We don't really know how many of these images you have to display, so that's another problem. And the solution I'd like to show you right now is a library called Android Query. We have downloaded it before on the Google Drive folder. Okay, we'll get back to it. Let's just get to it and just import this library. So it's going to be the other way of importing libraries, which is a bit easier. We just have to copy this file to the jar to our folder, to our project folder. In my case, it is this is API demo. And here is the main project folder, and in the libs subfolder, I'm now pasting our library. Then in the folder, package explorer in Eclipse, I just refresh it so that it's shown with packages explorer. There it is. And we have do is right click it, select build path, add to build path. And that's it. There. We need another building block to move on with our application, and that is actual parsing of JSON. Right? It's really easy compared, for example, to XML. Parsing step itself is very straightforward. We have two classes that help us with that: JSON array and JSON object, which are like the equivalents of array in JSON and the dictionary object in JSON. The way we use them is when we have an instance of JSON array, we call get string or get double or get JSON object. We specify the index in the array, we get the object of the specified format. And for JSON objects, we do exactly the same thing, but we provide the key under which this value is stored. So we can look, for example, like this. This code in our units, right? We will assign IDs of our object, right? Here we create an object of our classes that we've created before, and then parsing is just like, and we have a JSON object returned from any query. We'll get to that. But here is the Java version of the JSON representation of the piece of data we've actually received. It's just like that. We provide the keys under which those values are stored. These keys are specified by the API, so we know them. It's an external source. Everything is posted within the try catch block. So, for example, if there is no field in our JSON that has the ID field, or the key ID, an exception will be thrown and cached. Okay, so now the longest part of the demo, and let's get started with it. First thing we have to do to make available any integration, we have to get permission. Okay, so let's get the permission. Permissions are handled within our manifest file. You know the manifest, right, from previous lectures? Right. You can easily do it here. Permissions, add uses permission, and we select from the list Android permission, internet. And it's just like that, it's done. Next thing, custom Ajax callback to set the header. So maybe I'll first do it and then do some explanations. I'll create a new class called EESTEC API callback. That will be a subclass of one of the classes from the language query library. This is Ajax callback. Here I will overwrite the method run, so that before the request is actually run, there is a header added to the tag of JSON. So this is a little hack we need for our API. And we're going to use that class very soon. we created loading sign, loading indicator. So let's get back to using fragments. Here we will override method on create. This implementation in font. And what do we need to do now? We'll just make a new query object. That's the object. You may notice that handles all the operation. The under query library lets us. So let's just here. So here where we need to provide an argument to the activity, so we can just use the get activity here. Thank you. Ajax. There are several variations of this method. We can use the second one, where we specify the URL, the type that we expect to receive. In this case, it will be the JSON array class, to specify the class here. And as a callback, we can use a new instance of our EESTEC API callback that will make an anonymous class here by putting the curly braces. And within this anonymous class, we override the method callback, which will be run whenever the request comes back to us. So here we will set the here we will parse the result. It's generic type, so we forget one thing here. In our callback, and it's here written in the warning. Next, so row type. Therefore, we need to add something like this here and here. That's interesting. Just visible. Again. Now here we see that we need to specify the type. The type is here also a JSON array. The other thing we now need is the URL. And we get the URL from our API. So we get back to where we had our link. It's here. Remember the password. Yes. Let's just paste it here. Plus. Okay, so three parameters: URL, the return type, and the callback that will eventually parse the results and display it on this. object to parse views. Create this element and let it run the object that we received. It's not, this when there is an error, like a network error or something, we will get a null object here. We can class it here. Okay. Let's create a method for parsing the object. My suggestion is to handle the actual parsing step, a single element within the classes right here. So we can create a static method, static museum, so that the method will return actually an object of type museum. Let's call the method from JSON. And it will receive a JSON object. Okay. Return something. This one. Here, okay, we know that the JSON that we receive is in the form of an array that contains dictionaries. Maybe let's see if it's going to work. I'm going to put a debug breakpoint here. Let's just see what happens. Here. Null for now. We see here that we actually have the JSON with our data. Let's just wait. Let's see one row here. There are a few peculiar things here, like the all the dots or the periods in the URL are actually commas. So that's something we have to work around. It's just a plug in the API, but let's not talk about it. We'll handle it on our side. But from here we can also get the structure of a single item to be parsed. So let's just there's a nice site format so that it moves in a more human readable way. So we see the keys here and the values here. So let's write the parsing method in our using class. Create a new using object. Eventually return. And we're just taking keys from this object, getting the values, assigning them to the fields in just like this. D is ID. I'm taking the key value from when we set out the asynchronous request for that URL, and once it's executed and comes back, we get the JSON array already in place. So we parse it, and here for parsing, we just need to call the method from our museum class. How many times are there items in the array? So let's do it. So we need a loop here. 0 to museums. Each of the items in the JSON array, we create a museum just like this. Museum. From JSON, and here we go for museums. That's our JSON array. Yes, JSON object is in the first place. As an index, we just that is our counter in the loop. And here it also asks for a try catch block, because in fact you cannot guarantee that the element will be a JSON object. We just trust the API to return it. So here, and in the end, we have to, here we have, in this place, we already have the object parsed, so we just add it to our museum list. So we must add an object. And that's it. Okay, so here's the list. Actually make this method to return the list in the end. So after the loop finishes, we just return our list. Anyway, if you don't, are you following more or less things that are happening here on the screen? Okay. It will be just clear for you once you go through the code for yourself. If there are any questions, just feel free to interrupt. So next thing we need to do, we have a list. What else do we need for the list? We need the adapter. So we have to actually create it. So we need a class that we will call using adapter. And this time we subclass the base adapter, because this is going to be the adapter for the list that will display all the elements. So we're looking for a base adapter. Here we have a set of methods. Fill. First we will create a constructor. museums. I'll create a field. List. Structures. Context. Alright, let's just assign the values here from the arguments to our fields. List, context, context. What should the get count method return? Anybody? Come on.
Well,
Okay, there is something that we may. A good programmer is someone who looks at both sides of the road on a one-way street. So let's just make sure that the list is null. If it's null, then we can just return 0, and then return the length of the list, the size in this case. And if the list is actually null, return 0. Get item. Get item is the method that returns the actual item, in this case, and museum. So let's just change return type to museum. And the same case of if this is not null, return the element at the location specified by the condition. Other case is just return null. The item ID, we don't need this method right. Okay, that's it. And the real magic starts happening here in the get view. This method is responsible for creating the element of the list, populating it with the data. And there is one important thing about the get view method that it has to be executed quickly. And to ensure proper efficiency, we have to avoid assigning large or just doing some memory initializations, etc. So we want to reuse existing objects as much as we can. As you probably remember from yesterday, we can use the convert view to reuse the elements that were displayed previously but now are off screen. So let's make it like this. Just a bit of magic. I think the convert view is not null. And we just reuse it. Create a new view from the XML template that we had created before. Remember, most of the items in XML called item museum and item market. How do we do this? Assign to B. And here we have to inflate the XML. That is to create a view object from the XML representation. Do it by something like this layout inflator. First we get the instance of a layout inflator. We need a context for that. And we have one. So let's hit it. And now we just inflate our resource, which is under R layout choose the right R library. Because there are like 3 of them. We need the one from our project. Layout, item, visual. And as the root, we pass the node. Okay, so eventually we want to return so here, at this point, we have the view already initialized, and now we want to fill it with data. So, okay, we'll just finish up this method and make a brief pause. Let's see. We will diagonal. Just assign minus view by ID and we specify ID name, for example. And this will be text view. See that text view name. See that I'm not actually doing any memory allocation here. I'm just, all the allocation was done here just once. And here I'm just searching the view structure, the view tree to get me this view. Okay, so let's make it pause. We'll be back in like 15 minutes. And you want a copy of the current state of the app drive? Whoever has a USB drive
questa sono una cosa del top 5, e quelle di 5, perché c'è il top 5, quando entro. Poi mi ha detto che erano quelle solo 5. E se dopo uno da quello là vuole vedere semplicemente la lista normale, cioè in pratica come si posa un filtro, però un filtro e in più separa più di 5, quindi più fa passare dopo alla modalità normale, cioè giocatore indietro. Hai capito cosa intendo? Ma un filtro mostra solo i primi ricordi, non ha molto senso. Cioè, ho capito quello che dici tu, che in pratica sì, gli dai un senso, ma non ha molto senso. Oppure mettiamo una cosa che fa fare, un filtri. Cioè, non ho cosa da fare, però.
What are the experiences with titanium?
Yeah, we do open application type of things for it. Was cool, but in terms of performance, we have this version on iPad 2, not cool on iPad 1.
Faster?
Yeah, there you go. You are honest, but they are translating your JavaScript devices code into objects.
That's the goal.
Yeah, the translation is perfect. No, not so easy. Yeah, that's so easy. But you can get Objective-C codes in manually. It's cool.
Okay, so first you have to write the JavaScript, then you have to
Yeah, you have a lot of
secret,
yeah.
then you have to rewrite.
Yeah, you can write it. You know.
Yeah, but then you have that as like an something you have to if you change something.
Yeah, you have to change your JavaScript.
After the decision making, so one.
Now it's working.
Okay guys, let's say we can afford another 10 minutes for you to download the recent project version from the Drive and set it up in Eclipse, and we'll get back to it in 10 minutes. Time's time. Level 13. After importing the project, don't forget to attach the shell library again. You still have that project in your package store. I guess it should still be here. Okay. I can delete the previous session. Import the new one from the Google Drive and attach the library the same way we used before. We have the project. And go to project properties. Select image and add the library. Should be included. See then we can check it. We're under reference libraries. It should be here under query. Try to build the whole thing. Or no errors right now. Who's already got the project up and running? Anybody? One person.
It's exactly the same thing.
Maybe two. We can redo the hacking. This configuration somewhere.
I didn't want to push it. It's the one comes up there.
Just try running on emulators inside.
I don't There is that.
There is absolutely no issue.
It's not a problem.
file new, other, and with project and existing code.
Recall the EES API level and then level.
Don't you have the show as well?
That's the same thing. That there is no target and
Okay, please just use import both projects this way. The order doesn't matter.
copy it.
Yes.
That's not target set.
Properties of the project.
Yes, but it erases the method.
Oh. Is it maybe there was some problem during unzipping?
No, because I unzipped before the
Can you check in some kind of outer editor if the contents of that are really empty or it's just
No, there are not empty. I opened it before with not now they are empty. They are
just imagine zero.
but they were 1 or 2 kilobytes.
Try to unzip it once more for first start. Delete all the projects and actives together with those files. Start.
Yeah, it's fast.
Right, so can we start? We'll display the data in a minute. Okay, let's move on. And it's by finished now at this point. So we've got the same view. We also need the other text view, right? And the image view. Okay. So let's just get the reference for the category. Museums and outer. here is the item for the position. We are filling the view format. We have the position and we just need to get the item. So museum. And will be our item and the position. Now it's time to connect them to each other. So, let's say name, set text, and our text will be nav.name. Simple as that. Category. And category. Now for the image view. What we get from our API is only the URL of the image. And we can't just display that URL in an image. We have to download the image, maybe store it somewhere for cache, and do all kinds of things to make it really more efficient. And normally, we would have to spend quite a lot of time doing these things like downloading, resizing, caching, etc. But here's the part where our mighty Android query comes in, and we can handle all of that just with one line of code. First, we have to create ourselves a query so that we don't create the actual object here in the get view, as I've told you before. This method should run as quick as possible, and we'd like to avoid allocating unnecessary objects, so we just make it once in the constructor. A query. This query. And we pass it the context. Here in this line, let's say Q ID, so that the query objects, an object knows that we want to mess up with our image view, with custom image view. Now a query object is set to manipulate our image view, and we just do the image, use the image method, and here, as you can see, many different kinds. We use this one. Parameters here are the image URL, which we have from our API, whether to use memory cache and file cache. So you can see that it handles image caching automatically, just out of the box. You can set up a target width so that the downloaded image is scaled, so that you don't have to store on your disk and memory, in memory. The whole big image is just the size that you actually need. And a fallback ID, that is the ID of a drawable that will be placed in the image view until the actual image is downloaded. So let's do the method. What we'll use here is image URL. Cache. Why not? Target width. We know that the image is going to be 120 dBs. I can't remember if this value here is the line panels, everything you need to download and start it. Kind of beautiful. I just reminded one more thing that we had in our API here when we are parsing things. As I've shown before, the actual URL has, for some unknown reason, commas instead of periods. So we'll just work around that by doing replace all the commas with periods. Problems will emerge when the URL contains actually the commas that should be there, but for now, let's just leave it as it is. There was another keycap there. The image URLs were actually ending in the space, so we had to get rid of the space. So again, replace all the spaces with empty string. Okay, the website also needs this hack, unfortunately. So this is the way to go. Right? Everyone following?
Way to replace columns
Oh yeah, that's the URL. Website and the image URL. Our site, to which we'll come back later, doesn't have such problems. Adapter touching. So we get back to using the fragment. So I can let's just finish. Right. Everyone got this? These lines ready? This is a comma. This is a comma outside the parentheses. This is the period. So let's get back to using fragment. Here's the file of code that should actually display the list code. This method gives us the list of the museum objects. I just have to get some here. So assign it to a variable. Just put the list. Still, the object is not so assign the color braces. And here we will just set the list adapter. This is a method available right in the fragment because we are using the shadow list fragment, and it has some options like setting the adapter available upfront. And as the adapter give us a new instance of museum's adapter. Here we need to specify the context, so we can use the activity, and as the list of museums, we simply pass to the museum list. Okay, is that all? Let's try it. can see the screen orientation is handled automatically, right? So I can just rotate the phone and list is updated. Any questions?
Something missing from the presentation, other class. Something online.
Okay, but which class? Museum? Okay, so since we've got it already, for the archaeological sites, it's even easier because we can just copy some things, change from museum to arch site, and remove something from the data. So it's going to be very similar. In fact, I think we can do something like this. Okay, copying and pasting code is not a good practice. So we could abstract things away and just gather all the commonality between these two classes in some kind of superclass and just subclass to archetype. But right now we're not going to do this. So I'll just copy the museum adapter to archetype and rename it to archetypes adapter. Okay. Here's a massive list of errors. Let's that. I'll just find all the museum appearances in the code and simply replace them with archetype. It's just a quick and dirty method to replace all the occurrences here. And for the archetype, we have no category, so we can just delete it. We have no image, so we can delete also this line. So we can just make it lowercase. There we go. We can delete the gateway because we don't need it anymore. Unnecessary. That's it. Do this for the adapter. And also we need to do basically the same operation for the fragment because for now it's like empty. So we can just copy it all to our segment. Let's see if it works here as well. Museum to ArcSight adapter, we have to change one thing because what you have there, you don't have inside of the child called name, but actually the text view that we want to use is the camera view of the inflated layout, right? The layout item ArcSight is actually the text view. So, we don't have to use find view by ID. We can just use the V and cast it as a text view. So, this. Until now, or yeah, it's all.
Could you show the
From this, okay. This one here. Whole names. because on Resume we are shown that the actual listing object has been created. Here, in this place, we didn't know it was actually created. Here, for sure, because it was after a long time of network connection. And here, on Resume, we can just get the list view and add to it set on item with listener. And we write a new on item with listener. First import the actual listener class, and then add all the unimplemented methods. Actually, there's only one. Parameters don't have names from the line, so we can set them for ourselves. So the parameter as the actual value, as the position, what the view is, and its ID. The last one is the ID. Okay. We are in the on item click method, and now we can just get the item for the specific position from the other. So we call we'll assign it to using the reference. So let's create a reference to Museum and get list adapter. This is our museum adapter. We're calling the get item and position. Here we don't actually know that this type of adapter is our adapter. Therefore, we have to cast the object that we receive from here to a museum. But we're sure that the list adapter is actually our museum adapter, so we can safely use this cast. Okay. And now to open up the browser for a specific link, we have to use the intent. Were there intents mentioned yesterday or the week yesterday? So we just create an intent with an action of intent. Action view. Four times on the line. Okay, and we set the data as our URL, but in the form of an URI. So we use the URI parse. Here we provide the website of our museum. Once it's done, we can just start the activity with passing our intent. Let's run it. Let's slide to museums. Which one? We're redirected to the website. That's the point. See, it's working. New functionality in 10 to 20 lives by default in 5 minutes. So that's it. Anyone need some help? While working as supposed to. Anyone there?
You choose the art side.
Right side?
Okay, like
Yeah.
fragment.
Okay. data from JSON to our Java object representations and just show them the list format. And in the end, we've also added some functionality, interactivity, so that you click it and actually see it. And I guess that's it. Are there any questions? Is something still unclear? Or later, just by seeing the code, you'll be able to make it up on your own based on the things you've seen. Okay, so questions? Thank you very much. That will be the end for today. Thanks. code it as ESS API technology for the application.
Αλλά πρέπει να συμφωνήσουμε μαζί πως μαθηματικός παίζω με τους CSS από πίσω που παράγουν αυτοί για την εμφάνιση. Ξεκάθαρα για την παρουσίαση.
Όχι, κάτσε όλα.
Κάτσε. Μην τα χάσει. Στο πρώτο βίντεο πάμε συμφωνείτε τέτοιο μαθήμα που πρέπει να δεν μ' αρέσει την κάτι. Με τέτοιες ερωτήσεις έτσι για όταν το κάνει βίντεο την εμφάνιση γιατί μην κάνει να κάνεις. Με έτσι κολλήσεις σχήμα ο οποίος δεν ενδιαφέρει να πούμε ένα icon το οποίο δεν είναι τόσο εντυπωσιακό για παράδειγμα αυτό ή κάποιο άλλο, αλλά όλα είναι κοντά μεταξύ και απλές.
Have you seen Java Apocalypse?
Java Apocalypse?
Yes, the new one. Java Apocalypse.
I don't see. Java Apocalypse.
It's a Hollywood.
Ναι, αλλά δεν θα σου το κάνουμε.
An exhibition of Java
Okay.
and every year they publish a new.
Yeah, we're watching to translate for you.
Have you found it?
Yeah.
Yeah, Java Apocalypse. Java Apocalypse. Πρέπει να κομμάτια.
Ah, you're the new one. That's
Now I'm going